Humanity's journey to the stars has always been a story of bold dreams and hard lessons. In 2025, on the sunlit coast of South Texas, SpaceX's Starship program reached a defining moment. What began as sketches and steel rings became a living, breathing city of science, Starbase, dedicated to making humanity multiplanetary. This wasn't just about launching satellites, it was about building a reusable bridge to the Moon, Mars, and beyond. Every test, every launch, and every failure became a vital data point in the most ambitious engineering project ever attempted. The air at Starbase buzzed with anticipation and risk, as rockets were tested not in labs, but on the pad, with millions watching. SpaceX's philosophy, build, fly, fail, learn, repeat, accelerated progress at a pace that forced the world to rethink what's possible. 2025 marked a shift. The goal was no longer to visit other worlds, but to stay. The mission was to create a sustainable, affordable, and reliable way to travel between planets, just as we do between continents. The challenges were immense, but the potential reward was nothing less than the survival and expansion of human consciousness beyond Earth. Every weld, every line of code, every fiery ascent was fueled by this vision. The future of space travel was no longer a distant dream. It was unfolding, right now. The first half of 2025 saw SpaceX achieve what once seemed impossible: 3 Starship launches in under 6 months. Flight 7 in January ended with an upper stage explosion, but the Super Heavy booster was flawlessly caught by Mechazilla, a historic first. March's Flight 8 pushed further, the upper stage climbed higher before a hardware issue. But again the booster was caught with precision. 2 successful catches proved the ground-based recovery system worked, making rapid reusability a reality. In May, Flight 9's upper stage reached space and attempted a re-entry over the Indian Ocean, surviving long enough to validate key systems before breaking apart. Each mission, though not perfect, delivered invaluable data, and proved SpaceX could build and launch these giants at an unprecedented rate. The dream of catching a skyscraper-sized booster was no longer fantasy. It was engineering fact. The upper stage remained a challenge, but the booster's consistent success brought full reusability within reach. These hard-won victories set the stage for even greater ambitions in the year's second half. SpaceX was rewriting the rules of rocketry, one launch at a time. The world watched as the pace of progress accelerated. Progress in space is often marked by spectacular setbacks. On June 18, 2025, Starship S-36 exploded during a static fire test at Starbase, sending debris across Texas and even into Mexico. The cause, a pressurized tank failure, an essential component for feeding the powerful Raptor engines. The explosion delayed the flight schedule and drew international attention to the risks of rapid development. SpaceX's aggressive strategy is to push hardware to its limits on the ground, exposing weaknesses before flight. But this loss was more than hardware. It was a public lesson in the unforgiving physics of rocketry. Setbacks like S-36 force deep reflection, regulatory scrutiny, and public concern. Yet, in space exploration, failure is never the end. It's the start of the next chapter. The world waited to see how SpaceX would respond. SpaceX didn't pause after the S-36 explosion. They accelerated. Engineers immediately analyzed debris and data, turning failure into insight. Starship S-37, originally scheduled for later, was prepped for Flight 10 within weeks. This rapid turnaround is possible because Starbase operates more like a factory than a traditional rocket facility. Design changes and safety upgrades were implemented instantly, especially to the pressurized tank systems. New infrastructure, including a dedicated static fire stand, was fast-tracked to minimize future risks. The S-36 incident became a catalyst for improvement, not a roadblock. By July, S-37 had completed engine tests, ready for launch. SpaceX's resilience turned crisis into a showcase of engineering speed and adaptability. With lessons learned, SpaceX prepared for 2 pivotal missions, Flight 10 and Flight 11. Flight 10 aimed for a full mission profile, launch, in-space engine relight, and a controlled splashdown, testing the heat shield's limits. Success here would prove Starship's ability to survive re-entry and restart engines in space, crucial for Moon and Mars missions. Flight 11, scheduled for September, targeted the ultimate feat, catching both the Super Heavy booster and the Starship upper stage with Mechazilla. Catching the upper stage required a precise flip and burn and a gentle grab by the tower's arms, a first in rocketry. These flights would unite years of innovation, pushing Starship closer to operational reality. The stakes were high, but the excitement was higher. At the heart of SpaceX's vision is Mechazilla, a towering structure designed to catch rockets as they return from space. By eliminating heavy landing legs, Mechazilla saves mass and enables rapid turnaround, making rockets more like airplanes than disposable hardware. The successful booster catches in early 2025 proved this radical idea could work. The next challenge, catching the Starship upper stage, a delicate operation requiring pinpoint accuracy and flawless choreography. If successful, SpaceX would achieve full reusability, slashing launch costs and opening the door to massive space stations, lunar bases, and Mars colonies. Mechazilla isn't just about catching rockets, it's about catching a future where humanity is no longer Earthbound. The dream is bold, but with each catch, it inches closer to reality. The world is watching as the impossible becomes routine. Even as Starship V2 was being tested, SpaceX engineers were building the next leap, Starship V3. Debuting by late 2025, V3 features upgraded Raptor engines, a tougher heat shield, and new systems for staging and payloads. Every flight, success or failure, fed data into V3's design, turning setbacks into progress. The goal is Starship ready for real operations, safe enough for humans, robust enough for Mars. In August, SpaceX announced its first commercial Mars customer, the Italian Space Agency, making the Red Planet a concrete target. Elon Musk's plan send 5 uncrewed Starships to Mars as early as 2026, possibly with Optimus robots to prepare for humans. 2025 became the year Starship came of age, record launches, dramatic setbacks, and the first steps toward Mars. The journey is far from over, but the path is clearer than ever. SpaceX has shown that with determination and innovation, becoming a multiplanetary species is within reach. The next chapter in humanity's cosmic story is about to begin.